Okay, we have to factor completely and sketch the graph of the polynomial. So what I will do, I will first use a theorem called rational zero theorems. Rational zero theorem, which states that the zero or the root of any polynomial function is always on p over q, where p is the factor of the constant term here, factor of -6, q factor of 2. So we're going to list the factors because we have a lot of factors. So, but factors of p, the factors of p are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. These are the factors of -6. And q, the factors of q are plus or minus 1, plus or minus 2. Therefore, p over q will now be, that's this one divides the q. So this divides this and this. I'll have plus or minus 1 and plus or minus 1 over 2. Why this divides this and this? I have plus or minus 1 and plus or minus 2. So we write plus or minus 2 since we have plus or minus 1 already. This divides this and this. I have plus or minus 3 and plus or minus 3 over 2. So why this divides this and this? I have plus or minus 6 and plus or minus 3. So we just write plus or minus 6 because we have this already. So it's telling us that out of all these, some of them will be the possible zeros of this polynomial function. So if you are testing, we'll test with this range of factors or roots. So what do? I will choose from this and I will use my synthetic division to know whether is a factor of this. So using synthetic division, I will test using -1. So I will first root to test. Let me use -1. So taking the coefficients of this, I have 2, -9, 6, 11, and -6. So if the remainder is 0, means there is a factor. So remember how we do it, synthetic division, bring down the number here, which is 2. -1 times 2 is -2, add -11, multiply 11, add 17, multiply -17, add -6, multiply plus 6, add 0. So the remainder is 0. So since the remainder is 0 implies that x minus s equal to -1, so meaning that x plus 1 is a factor. And if you notice, the numbers down here alternate in sign, plus minus minus plus plus minus plus. So what is the conclusion? You see that is a root and it is also the lower bound. We've done lower bound theorem. Lower bound means that there is no other roots here or 0 that is less than -1 that will be a root of this function, of this polynomial function. Yes, lowest root here is -1. So whenever you get numbers alternating in sign, that's the, this is the quotient, the coefficient of the quotient. Whenever the coefficient of the quotient alternates in sign and also with the remainder is part of it, you know that we have a lower bound. So that will guide us. We are not choosing any number again less than -1. So anything we are picking must be from -1 up. So it's a very nice, we are applying a lot of theorems to make this easier. So meaning our factor now, fx, could be written as x plus 1 since it's a factor, while this is the coefficient of the quotient. So all this now, fs is now equal to x plus 1 times 2x cubed minus 11x plus 17x minus 6. So again, we'll test using any of these except numbers less than -1 because we've seen our lower bound. So whenever you are testing, just don't test the lowest number. Just start from maybe, like I have the lowest here is -6, -3, -3/2. I chose -1, and I've noticed that is the lower bound. So I will never choose -6, -3/2, making the solution faster. So let's continue with our test. So I will choose from this factor. I will choose, let me choose another one, which is, let's choose 2. Because I always choose the lower, a negative and positive, to know whether I will get a lower and upper bound. So let me choose 2 because I have the highest 6. I have 3. But let me choose 2. Let's test using 2. So again, using our synthetic division. So I'll write the because this is already factored. I'll write the coefficients of this 2 minus 11. This is squared. Sorry, this should be squared. This is squared. Minus 11 plus 17 minus 6. So I say let's choose 2. So I always pick negative, positive to know whether you can get lower and upper bound. So I have 2 times 2, 4, add minus 7, 2 times that minus 14, add 3, 2 times 3, 6, add 0. Again, I have a remainder 0. And again, the thing alternates between plus minus. But there is one thing, this is not a lower bound. A lower bound must be a negative number. So a lower bound, because someone will ask me, is also, we have also plus, minus, minus, plus, plus. No, a positive number cannot be a lower bound. So from our previous video, I told you lower bound must be less than 0. Upper bound must be greater than 0. So note that. So we can now factor this again further. This one is settled. So this could be factored as x, since this is part of, this is the root, it's part of the 0. So we have x minus 2. While the remaining here is what? 2x squared minus 7x plus 3. So we are factoring further. But looking at this, it's easier for us to complete, yes. Because this is now a quadratic. The last factor here is a quadratic, so which is 2x minus 1 and x minus 3. The list, plus or minus 3 is part of it. And the root cannot be minus 3 again. Do you get? Because the lower bound is minus 1. So that's why I had to choose. And also 1/2. Half is also plus or minus half. So that is why I chose minus 3. So I know this should be minus 1. So we factored completing using synthetic division, and that's using rational zeros. So the next thing is to sketch. And in sketching this, we apply some steps. So there are some steps we use in sketching graph. So we first of all find the x-intercept, that is substituting this as 0. And we can do this, it's very simple. Therefore, if you substitute f of x as 0, as we are looking for x-intercepts or the zeros, so that is f of x is 0. So we see that 0 is equal to x plus 1, x minus 2, x minus 1, x minus 3, which implies that x must be minus 1, 2, half, and 3. So these are the possible, that's the roots, the intercept, the x-intercept. So the next is to get the y-intercept from the rules. I've done it in my previous videos. So to find the y-intercept means x is 0. So if I substitute x as 0, therefore the y-intercept means what? X is 0. So that is f of 0 now. We substitute x as 0. So I have 0 plus 1 times 0 minus 2, 2 times 0 minus 1, 0 minus 3. So I have minus 6. So f of 0, yes, that's 1 times minus 2, minus 2 times minus 1, 2, 2 times minus 3, minus 6. Okay, so our y-intercept is minus 6. So the next step is to determine if the graph of f crosses or touches the x-axis as each intercept. So how do you know? Here's what we call multiplicity. Multiplicity is the power. So if you look at the function, the polynomial function, you see that the powers are 1, they are odd, which they are all 1, 1, 1. So meaning, so since the powers of the factor are all odd, implies that they will cross at the various roots or zeros. So they will all cross, they won't touch, because some graph will just touch and go, but it must cross the x-intercept, it must cross. So that's, we've done that. So since their powers are all odd, so it's 1, 1 each. So the next step is to, we've known that they will cross, check for the endpoint, end behavior. So the end behavior will help us to know how we have four cases. So look at this. Whenever you are given a polynomial function, the end behavior depends on the power, the highest degree. So from here, our highest degree is 4. So it's either this, the first one, or the second one. We'll have 4 graphs here. So since it's even, it's either this first one or the second one. But if it's the first one, means that the coefficient of that highest power is positive. And from what we are seeing, the coefficient is 2. The coefficient of the highest power, which is 4. The highest power is 4. The coefficient, our a subscript n, is positive. So the graph will look like this. First one, it will end like this. So that's it. After we've plotted, it must end like this. So we've noted that one. So let's check. So the next one is to determine the maximum number of turning points on the graph of f. So determine the maximum number of turning points on the graph. So the maximum number of turning points is always n minus 1. So maximum number of turning points So this is just the maximum number that the polynomial will turn. So which is n minus 1. And from our factored for from the original, you see that the highest power is 4. So 4 minus 1 is 3. So that's it. It will turn at most 3. So all these steps will guide us in sketching the graph. So the other one, they say use the s-intercepts to find the interval on which the graph will be above. So this one is now another work, so that the graph will cross, because we have odd powers. It will cross at minus 1, 2, half, and 3. But between these numbers, the graph should either go up, that will be above x-axis, or it will be below x-axis. So we don't know whether it will be above or below. So what we'll do is to create a, maybe like a table, choose numbers between these to guide us to know how it will look like. So in that essence, we're going to use table. To that effect, we're going to use table. So from here, the table, like you can see, the roots are, we'll start from the smallest. The smallest is -1, half, 2, and 3. Okay. But remember, since we have our y-intercept is -6, so we include 0 because there is a gap. We have -1, do you get, before these positive ones, and I will have our y-intercept to be -6. So there will be a gap between, I can't just move from -1 to half, so I will include 0. Yes, since it's between the positive and negative. So I will split the intervals now. We have numbers less than minus the lowest one, numbers between -1 and, I told you, 0, numbers between 0 and, what was the next root? Half. Numbers between half and 2, numbers between 2 and 3, finally numbers greater than 3. Yes, we are going to test all this to guide us. So I'm saying that aside these roots, aside the roots, we need to know the behavior numbers between, that's greater than 3, less than -1, between -1, to get the curvature, that is how the length the thing will go down or move up. It will help us. So let's test. Remember, our function is this. Let's copy it so that it will help us. We factored it, so it's now easy. Let's test f of numbers between, that's less than -1. Let's test f of -2. So f of -2, let's see what we'll get. F of -2 is less than -1. -2 is less than, so let's test -2 plus 1 times, okay. We need to use the factored form, the ones that factor. Okay, let's swipe this. Let's use the one that is already factored completely. We have x, I think x, we have half that, half 2, 3. So let's check. X minus 2, 2s, s minus 2, s, that's 2x minus 1, and x minus 3. So let's test. This is -2. Okay, let's just be writing direct. This is -4, so let's not waste time. This is minus 5. This is -5. So what do you get? This is -2 plus 1 is -1 times -4 times -5 times -5. So this is 100. So we tested f of f of -2 and we got 100. We tested f of -2 and it gave us 100. And 100, the sign is positive, and means it is, since it's positive, is above. So let's test numbers between -1 and 0. So let's test -half. Let's test -half. -half, because it's between -1 and 0. So let's test. -half plus 1 is half, times -half minus 2 and half, which is -5/2, times minus half that. This is, I think, this 2 minus 1 minus 2 is minus 1 minus 1 is minus 2 times minus 1 over 2 minus 3 over is minus 3 and a half. That is minus 7 over 2. So let's see what we get. 2 as minus 35 over 4. Yes. So this is, we tested f of minus half. Tested f of minus half. And it gave us minus 35 over 4. Which is negative, which means below. So let's test numbers between 0 and half. 1 over 4. So which is 1 over 4 plus that is 5 over 4. I'm substituting 1 over 4 minus 2. 1 over 4 minus 2 is minus 7 over 4. So times 2 times 1 over 4. 1 over 4 is half. 1 over 4 will cancel 2. So half minus 1 is minus half. Times 1 over 4 minus that is a minus 11 over 4. Let's put it in the table. So we tested f of 1 over 4 and it gave us minus 385 over 128. So this is negative and this means below. So let's test numbers between half and 2, which is 1. Let's test 1. Let's test 1. F of 1, which is 1 plus 1 is 2. 1 minus that is minus 2 is minus 1. 2 minus 1 is 1. This 1 minus that is minus 2. So I get minus 2. Minus 2 times minus 2 is 4. So f of that, okay, let's just finish. I will now put it once. F of between 2 and 3, 5 over 2, that's 2.5. So I have 5 over 2 plus that is 7 over, plus 1 is 7 over 2. 5 over 2, that's 2.5 minus that is half, minus 2 is half. 5 over 2, that's 2 times 5 over 2 minus 1 is 5 minus 1, I think 4. 5 over 2 minus 3 is minus 1 over 2. That's 6 minus 5 minus, okay. So we have 2, so I have minus 7 over 2. So finally, numbers greater than 3, let's choose 4. F of 4. So this is 5 times 4 minus that is 2 times 7, because 2 times 4, 8 minus that, times 4 minus 3 is 1. So I have 7th. So let's put in the values so that we'll plot the graph now. So we substituted f of 1 and it gave us 4. That means positive, means above. We substituted f of 5 over 2, gave us minus 7 over 2, which is negative, meaning below. So finally, we substituted f of 4, and it gave us 7th, which is positive, meaning above. So we're going to use this to plot the graph. So let's sketch the graph. Okay, let's plot. So remember, our roots are minus 1. That's minus 1. Half should come nearer here. have 2 and 3. So 2 should go somewhere. We have 3. So these are the roots. That's the ones that will intersect the x-axis. So these are the points. And we've got our y-intercept as -6. So we need to put it -6. So let's make it here -6. So this is also one of the points on the graph. So but we now tested using some intervals. So we tested -2 and I got 100. So we still add it so that we know whether it will go up or down. So I tested using -2 and we got 100. So let's 100 be, I think that's the highest. Let's use this 100. That's part of the points. So we didn't label the axis. Let's label y, x, and the origin 0. So let's continue. So which other point? We tested between -1 and 0. So between -1 and 0, -half, we got -35/4. So we tested -half and we got -35.4 is -7 point something. So it should go down a little, it should be more. So somewhere here. So this is -35/4. So from there it will intersect this. So let's check 0, and between 0 and we tested 1/4. And we got 1/4. We got -385/1. That's -3 point something. -3 point something. This is -6. So -3 will be nearer. So -3 point something. So it will, let's make it this point. It will be -3 point something. Yes. Maybe let's use yellow. So this is one of the points. So which other? Between half and 2, we chose 1. So 1. So what did you get? 1, 4. Okay, +4. So we got 4. So this minus, so 4 should be down a little. That this minus come closer a little. So 4 is this. This is the point. 1, 4. So between this will intersect. So between 2 and 3. Between 2 and 3, we chose 2.5. That's 5/2. I have -7/2. That's -2 point something. So -2 point something will be somewhere here. So that's one of the points. So before we now choose above 3, which is 4. We chose 4 and we got 70. So let's include 4 here. We got 70. So this 100. So 70. Let's make it somewhere here. This 70. So let's now join the points. So let's join. We'll start with this. So cross it at this point. I'll make it tick later. Goes this way. This way. This way. This way. This way. This way. This way, and finally. So that's our graph. So let's color it. Let's make it red. Let's bold it. So that's it. That's the graph. If you sketch it, that's how it will go. So if you remember, our endpoint, it ended, if you could remember, when we tested the endpoint, both of them, do you see it? So this is the graph of, is now the graph of fx equal to this fx equal to x plus 1 times x minus 2 times x 2x minus 1 times x minus 3. So this is our graph. So you can verify by using an app to graph. So that's how it will go, though we are sketching, so you can't compare the ones with app. So that's it.